My name is Dean Blacc. I'm a design engineer at GitHub, but as you may have surmised already, I am not going to be talking about anything GitHub related. Instead, I wanted to use this time. So before I worked at GitHub, I worked as a computational artist. Sometimes you may have heard the term used, generative artist. I prefer not to use that term because when people hear generative, sometimes they think AI, and actually that's nothing to do with what we're going to be talking about today. So these are basically I would write algorithms that produce art as output. And so these are some outputs that come from writing entirely just JavaScript. And often I would spend time doing things like texture studies. So I thought maybe I could walk you guys through what it's like to go through a texture study and producing textures exactly like this and that kind of thing. So just so we all know what we're gonna go through for the next, I guess about 18 minutes or so, is a quick agenda. So thought we could start with a quick definition of what computational art is, make sure we're all on the same page and understand what's going on there. And then we're going to actually dive into creating this kind of painterly texture that you see on the right-hand side, which is from an algorithm I call color computer. But yeah, we're going to be focusing mostly on the texture. And in order to do that, we'll first talk about some tooling and noise algorithms. Anyone familiar with noise, worked with noise before? You have? Oh, awesome, great. So you can call me out if I'm talking rubbish. And then we'll look at how we can apply noise to create texture. And finally, what adjusting parameters means for some of our outputs and why sometimes it's called parametric art. And finally, we'll have some time for some questions, hopefully. I actually have less time than I thought I did, so some bits, I'm not gonna lie, are gonna be a little like this. I will try and call them out before it happened, but yeah, bear with me at those points, because it's just so much detail and it's like, just for the sake of time. So with that said, what is computational art? So computational art is an art form in which an artist develops a system for the creation of individual works. Today's computational art typically entails the creation of an algorithm using computer code. Randomness is introduced to the artist's algorithm and the system outputs a unique artwork. So don't worry if you don't understand what the randomness has to do with anything just yet. Hopefully we'll walk through some examples and we'll see exactly how we use randomness. But as an example, these outputs that you see on the right-hand side are from an algorithm I wrote called Good Computer. And basically you want to write an algorithm, so every time you run it, it produces a new output. So you kind of write the rules around the algorithm rather than the output, if that makes sense. So even when I refresh it, I don't exactly know what's going to come out. I only have like a general idea. So that's the kind of thing that we do with computational art. So yeah, let's dive into some fundamentals that we need for creating these kind of textures. I typically use P5.js. Anyone familiar with P5? Anyone used it? Oh, awesome, loads of people. Oh, great, that's fantastic. So it's basically just a wrapper around the Canvas API where, Canvas API allows you to render to the HTML canvas. P5.js basically gives you some convenience functions. So as an example, this is writing directly to using the Canvas API. And by comparison, we can see here, it's basically the same thing. Both of these snippets create a circle of 160 pixels in diameter and fill the pixel. Now, I guess you could argue that the first, with the Canvas API, kind of gives you greater control because you have more variables to use and that kind of thing. But personally, I've never had any issues using just P5. And then the next important thing is Perlin noise. No one else said they'd use Perlin noise, right? I think it was just, oh, you have, awesome. What did you use it for? Just kind of curious.
I have like a randomized shader tool.
Oh, cool. Oh, nice. So you'll be familiar with like.
I mean, it's mostly vibe coded, so I.
Okay. Still, cool. Awesome.
But it looks awesome.
Cool. So, I guess as a definition for Perlin noise or noise in general, for those who aren't familiar with it, I think about it as like randomness with continuity. And that might sound like a bit of a paradox, but in the next slide, we'll dive into an example and we'll see how randomness. Genuine random numbers compared to using using Perlin noise to generate your randomness. And then we'll start applying it to an image. So just a quick detour. Perlin noise was created by this guy called Ken Perlin, hence Perlin noise. It was first used in Tron in 1982. And when it came out, it was like the graphics, everyone was like, whoa, this is like so realistic. And actually Ken Perlin actually went on to win a like an Oscar or a nomination or award for like technical achievement in the 90s or something like that. And today, pretty much any movie that you watch that uses CGI or any video game that you play that produces textures will be using some form of noise. May not be Perlin noise, but it'll be a derivative of it, maybe simplex noise. There are all these different kinds of algorithms out these days. Yeah, so I'm not going to be doing too much code today. This is pretty much the extent of what we're going to be looking at in terms of code. The rest of it will be very high level. But all I'm doing here is plotting 50 random numbers across an x-axis. And as you can see with the output, it's jittery, it's all over the place. There is no connection or anything like that to the numbers that came before or the numbers that come afterwards. And it looks exactly what you would expect, like you would expect when producing 50 random numbers, right? So by comparison, so you can just see we have a for loop here, and it basically is just picking a random number between 0 and 250 and then drawing the vertex in that point. So let's compare that to using a noise algorithm. And you can see the output already is dramatically different. And again, all we're doing here is we're using this noise function. I don't have the line numbers, but you can see inside this for loop, we call this noise function with this xof variable, which I'll talk about in a second. And what that gives us back is a number between 1 and 0, and then I map it to 0 and 250. Now this noise function, all it does is when you ask it for a random number, it will give you a random number that is related to the last random number that you used. So when you see this xof value here, you can kind of think of that as a delta. So when I produce my first number, I move the delta a bit further, and it kind of gives me the next number that is sort of related to the number I used before. Sometimes it can be very similar, it really depends, it's random, but it won't be all over the place. If I increase this xof to something like, I don't know, 0.5, then the value that comes out when I call noise will be like very far away from the initial value that I produced. Hopefully that makes sense. Cool, yeah, it's lots and lots, that's great. So we start to get this kind of smooth kind of line. And this is when we use noise in one dimension. It is possible to use noise in 2 dimensions, which is exactly what we're going to look at now. So we have reached our first draw the owl moment here. So bear with me. So we're going to use 2D noise. We've just seen it in 1 dimension, and we're going to now apply it in 2 dimensions. So we're going to start getting like curves and that kind of thing. And we're going to use that as the basis for the paths that we're going to draw, which are going to represent our brushstrokes. So we get our first line there. It's nothing remarkable. Like if we zoom in a bit, we can see it's not exactly a straight line, but it is also kind of curved, just 6 vertex there. And basically this one line is going to form the basis of where I'm going to draw my brushstroke, or figurative brushstroke at least. Now, what I need to do before I draw that brushstroke is actually fill the canvas with similar lines, similar kind of paths for our brushstroke. But what I don't want to do is have those lines overlap, and I want them a certain distance away from each other. So again, this is mostly technical detail, so I'm not going to go too deep into it. But the way I do that is for every single vertex, we check around that vertex at a certain distance. We can define how far away we want that distance to be. In this case, I think it's like 10 pixels. And these green points, we're going to add to a queue. And they're going to serve as potential points for where we're going to draw our next line, or next path, I'll call them. So yeah, we randomly pick one of these lines once they're in a queue, and then we decide, is this point valid for me to start drawing a line from here? And it's only valid if there are no other lines within within like 10 pixels, for example, in this example at least. So again, just the implementation detail, not really worrying about that. Like I said, we're just going to draw the owl. So you can see we've drawn our second line, and as the algorithm, we just continue this process, and the algorithm slowly builds up the page, as you can see it's happening. And we start to get this kind of almost like wood-like effect almost. And you can see the paths, and we can see the noise start to show through. So we run this algorithm until we have no more points in our queue, and we have this kind of nice kind of flowing. It's not perfect. There are some gaps in there, but that's actually going to serve a good purpose for us later on. We'll see. But yeah, we're gonna use this as the basis of our drawing and where we're gonna paint. So taking a step back, like if we just focus on these first 50 or so paths that we generated, the next thing I wanna do is kind of start to think about how a brushstroke in real life interacts with paper and how we can kind of replicate that digitally. So when you think about a paintbrush, it has lots of bristles, right? Like we don't just draw one line. When it interacts with the paper, it's never entirely even. The bristles are always kind of slightly unevenly spaced. So that's the kind of thing I want to kind of try and replicate here. And I'm going to do that by drawing, let's zoom in, by drawing so as you can see, we're just going to take the first line and we're just going to draw that same line multiple times with slightly varying widths to represent each bristle. Everyone with me? Awesome, cool. So let's just continue the process and like start filling out the paths that we have here and see what that looks like. So you can kind of start to see where we're going with this. I'm not sure if the color is coming out great, but you can kind of see where we're going, right? It's starting to look a little bit like, maybe we're kind of getting some kind of, strokes going kind of thing. But when I look at this, you see computers are very good at doing things perfectly every time. So the challenge for me is always trying to find where the computer is showing itself and try and hide those bits. So when I look at this, you can kind of see some of these edges are like very straight, very angled, as you would expect a computer to produce. And that's not what you would have with a human hand or a brush, right? So what we want to try and do now is kind of just dial up the chaos a bit. So when we think about a paintbrush, the bristles kind of all over the place and they don't always touch the paper at the same time. So what I'm going to do here is have these bristles kind of start at slightly different places. And this is a very subtle change, but it does make a huge difference. So if you blink, you might miss it. But see, now it's kind of just dialing up the chaos just a little bit. It's a subtle change, but again, it does make a difference. So if we continue, these are our paths that we had previously, and we're just going to fill these out. So you can start to see the canvas is getting a bit more full. But again, I'm looking at this and I'm thinking to myself, this kind of looks a bit flat. And in real life, if I was painting, it wouldn't be one color, right? Like sometimes you have more paint on your brush, sometimes you have less, sometimes you apply more pressure, sometimes bits have dried, sometimes bits are more wet than other pieces. So how can we kind of represent that in our drawing? And one way to do that is to play with saturation. So for every single brush stroke now that I've drawn, every time it's drawn, I want to adjust the saturation just a tiny bit, not too much, but just enough so you can kind of see that difference. So if we look closely, you start to see, now we kind of get this texture where it's looking like, oh, maybe this was painted, on top of each other, and you kind of start getting some depth in there. So again, let's continue and see how this looks when we fill out our canvas. These are the paths that we generated the first time. And this is kind of where it doesn't, it's not amazing. It's not terrible either, but you can kind of see we're on our way there, right? Now, if this was your first iteration at painting a canvas, you might look at this and say, well, there's lots of gaps here. What can I do about that? And what we're going to do is basically apply the exact same technique, just on another layer. So we're just going to paint on top with the exact same thing that we've just done. So I apply another layer, and you can kind of see now, right? Like we're starting to get on our way. But there's still kind of these gaps there. So let's apply one more layer. Why not? And this is what we got, which is looking better. But in my opinion, and this is the thing about art, it's not necessarily like design. It's very much about taste and what you're trying to go for. So some people might be happy with this, but this is not what I was trying to achieve. To me, this looks very like I'm using felt tip almost. And I kind of want to soften the image a bit. I don't want it to be so hard. So one way of doing that, we've already played with saturation. Why not play with opacity? So right now we're drawing every single one of these brushstrokes and these lines at 100% opacity. And what if for every single brushstroke we produce the brushstroke at an opacity between 8% and 20%? Let's see what kind of effects that might have. You kind of see we start to get this kind of a lot softer feeling, right? It feels a bit powdery almost, but the gaps have started to show a bit more as well. The edges are a lot softer also. And you know, again, like I was saying, because it's so subjective, some people might be happy with this. For what I wanted to go for, I want to apply one more layer just to see how that looks. And it looks like this, which is kind of the texture where I wanted to add. And this is kind of what I was looking for. I think it balances the right amount of like gaps and almost human-centric errors with depth without being overwhelming and kind of distracting. So yeah, that's how to produce an algorithm or a texture like this. But we don't have to stop there. Like we can adjust parameters, right? Like as I used in that last algorithm, the stroke widths were at a certain range. Like if we set those stroke widths a lot shorter, we start to get an effect that we see in this first one here, where it kind of looks like, you can see the strokes are a lot shorter, but it produces a lot more gaps. And that's not necessarily bad. Again, it really depends on what your goal is and your intent is. In the middle, we can make the computer only draw bidirectionally, so north to south or east to west, and it gives you a completely different type of texture. And in the last one, if you remember when I was showing the Perlin noise, there was that delta value, the X off. If we increase that, what you start to have is get these strokes that are a lot more wild, and it kind of gives you this feeling like maybe it was painted by a child or someone that was like in a rush. So again, it really depends on what you're trying to achieve and what your purpose is. But I think the mark of a good algorithm kind of will use these parameters in different ways. And every time you hit refresh, it will give you maybe it will combine some of these parameters and it'll give you something maybe you haven't seen. But yeah, it's really just about exploring that and creating that possibility space. And yeah, just kind of a good algorithm, you'll just keep hitting refresh just to see, you know, what comes out. If that was any kind of interesting, then there's some further reading here. I did not actually finish this list, forgive me. So usually with my work, because I like to simulate analog textures, I also like to print them. So I bought this really expensive printer and I started getting really into paper, actually. You'd be surprised how deep it gets. So I like to print them and I like to like hang them around the house and that kind of thing. And that's one of the results. And yeah, that's my talk. I'd love to hear any questions.